Hey guys, so welcome back. Hopefully in the last couple of videos you were able to look at the phase diagrams and the vapor pressure charts down here and get that figured out. So what we're going to look at today is what we'll call a heating curve. Okay, so heating curves, I want to be sure and explain the difference in a heating curve and a phase diagram first. So a phase diagram, the area between and around the line shows us what phase of matter we're in based on the relationship between pressure and temperature. So heating curves happen at a constant pressure, and it relates temperature change and heat being added or energy being added. Okay, so it shows us as the temperature changes, we can deduce when heating is occurring as well as when phase changes happen. Okay, so if we look at just the first diagram, this is just a generic diagram for some generic compound. We have heat or energy on the x-axis, temperature in degrees Celsius on the y. So we can see that if we start off at the very lowest temperature, we can assume at the very lowest temperature that the substance is a solid. Okay, so down here we have a substance as a solid, and as we add heat, okay, so going to the right, you add heat, the temperature steadily increases, which is what we expect. But then all of a sudden you get to a point where you add more heat, but the temperature doesn't increase. So that's a little bit strange. So think about what might be happening when you get to a point with the solid where you continue to add heat, but for a little amount there, the temperature doesn't increase. So hopefully you thought, well, that's where melting happens, because we know that temperature does not change during a phase change. So right here, we could label that as the heating of a solid. Then right here, we could say that is the phase change from solid to liquid. So now we have a liquid, we continue to add more heat, more energy, the temperature steadily increases, but then we get to a point where we no longer see a temperature increase. We add more heat and the temperature stops increasing. So you can probably imagine there, well, that's where another phase change happens. Then the line got cut off on the note. There should be a line like that. So the phase change occurs, and then we continue to add more heat, and the temperature again begins to increase. So we're heating a gas there. So if I want to label this, I can label this line as heating a gas. I can label this line as heating a liquid. I can label this line down here as, I'll write it up here, heating solid. That's what I mean, what is the heat or energy being used to do? So we could label energy is probably a better phrase to use there. So it's increasing the temperature of a solid, increasing the temperature of a liquid, increasing the temperature of a gas. So then on these horizontal lines, I can say here I'm transitioning from a liquid to a gas, and here I'm transitioning from a solid to a liquid. Okay? So that is really what a heating curve shows me. It shows me where the phase changes happen. So using this, I could, at this given pressure, figure out what the boiling point is right here, and then what the freezing or melting point is right there as well. Okay, so there are some questions down here that we can look through. Oops, sorry, you can't see. Adjust the camera. Down here at the bottom, let's look through together based on this bottom heating curve. Okay, so first, let's ask, what is the freezing point of the substance? So, well, we have to ask, where does freezing occur? So freezing is the liquid to solid phase change. Okay? So the liquid to solid phase change is this little step right here, B. So it is 5 degrees Celsius. Okay? So it freezes and it both melts at 5 degrees Celsius. That is the temperature where the solid to liquid phase change happens. So then what is the boiling point of the substance? So I wrote the temperature. You could also write the letter where it happens. So D, this is the liquid to gas phase change, which will be boiling. So we can say it's about 15 degrees Celsius. So then it asks, what is the melting point of the substance? So we know that melting and freezing are opposite processes. So both melting and freezing happen at 5 degrees Celsius. So then it asks, what letter represents the range where the solid is being warmed? So we're heating a solid here on A, the slanted line right here. What represents the range where the liquid is being warmed? We have C. We're warming a liquid there. What represents the range where a vapor or a gas is being warmed? That would be E, right up here. Which letter represents the melting of a solid? We already answered that really. B, we're melting. Vaporization is at D. Which letter represents condensation? So condensation is the opposite of vaporization, so D. And then crystallization is not a word we use a whole lot, okay, but crystallization can be used to describe the phase change from a liquid to a solid. So again, that would be B. Okay? So hopefully that makes sense. Answer all those questions pretty straightforward. If that doesn't, pause the video, think about it, or shoot me an email and ask me your question. So that should be pretty straightforward as far as interpreting a phase diagram. So now what I want to do after, and you can go and answer this question in your own words, make sure you have those 3 different things straight. But I want to label this phase diagram. There's 1, 2, 3, 4, 5 different regions here. And I want to label with each region which of the 3 formulas that we have that we would use to calculate the amount of energy. Okay, so let's think about that real quick. Let's do the easier ones first. So I have a formula associated with melting or freezing. So that is my Q equals HFM. Okay, so for this plateau right here, this area, I'm going to use the formula Q equals HFM to determine the energy being added, or energy that needs to be added to carry out that transformation. Then right here, I will have Q equals HVM. Okay, so for the 2 phase changes, I have 2 different formulas that allow me to determine the energy required for that transformation. Then, for all these changes, I'll have the same formula. Q equals MC delta T. Q equals MC delta T. Q equals MC delta T. But the C value will be different for each of these. So we'll have a C for the solid, C for a liquid, and C for the gas. Okay? So let's just say, let me grab another color pen. I want to calculate the energy required to melt a substance. Okay? I could just use this right here. Okay? So to melt a substance, I could use Q equals HFM. But let's say I want to calculate the energy required to change a cold solid, so a solid below freezing point, all the way to a gas above freezing point. Okay, I want to go from there to there. How do I calculate that? And the answer is you have to account for each step on your energy diagram. First, you have to decide how much energy is necessary to heat from the cold solid to the solid at melting point, 5 degrees Celsius. So I use Q equals MC delta T to go from here to here. Then I have to melt the substance. So I use Q equals HFM to figure out how much energy is required to melt. Then after I melted, I have to heat my liquid to the boiling point. So I have to figure out, using Q equals MC delta T, how much energy is required to heat from 5 to 15. Then I have to vaporize. So I figure out how much energy is required to vaporize that substance, to go from here to here. Then I have to figure out how much energy is required to heat the gas from here to here. And I would use Q equals MC delta T for that. Okay? So potentially, you might have to add 1, 2, 3, 4, 5 different steps to the calculation together. Okay? Or if you just wanted to go from here to here, for example, on the phase diagram, or let's do better yet. Let's just do from here to there. That's a better example. I would have to do MC delta T to heat the liquid. I would have to do Q equals HVM to vaporize the liquid, then Q equals MC delta T again to heat the gas. Okay, so hopefully that makes sense on when to use those based on what transition we're trying to accomplish. Then in the next video we will begin applying these calculations, or applying this to calculations. Okay, so make sure you take a second, label your diagram, take a minute to kind of marinate on this and absorb this, and also make sure you can answer these questions. Then in the next video, we will look at some examples together.